are going to see machine learning based Internet of Things system for COVID-19 epidemics. Introduction. With remote monitoring and real-time health systems enabled by Internet of Things development, smart cities and healthcare are made possible. Internet of Things systems can boost public safety during the COVID-19 pandemic, use drones for delivery, supply and disinfection, and track geolocation. AI-assisted sensors are able to anticipate infections and stop their spread. These platforms must prioritize security and data management in order to enable potential long-term surveillance after the pandemic. Objective of the project. Internet of Things devices monitor the environment and search for patients during the COVID-19 pandemic. The San Francisco Internet of Things sensor genes data is used to apply AB feature selection algorithm to eliminate noise and unimportant features. The project compares LSVM, QSVM and traditional live-based algorithms to determine the best model for COVID-19 disease prediction. To execute this project, these are the requirements needed. Hardware requirements: operating system of Windows, processor of i5 and above, RAM of 4GB and above, hard disk of 20GB and above. Software requirements are Python IDL of Python 3.7 version. To execute this project, we have designed the following modules. The first module is upload COVID-19 genes dataset. Using this module, we will upload COVID-19 genes Internet of Things dataset and then display graph of various COVID-19 diseases. The next module is preprocessed dataset. Using this module, we will replace missing values, shuffle and normalize dataset values. The next module is run AB feature selection algorithm. Using this module, we will apply ABE algorithm to select relevant features and then split dataset into train and test, where application uses 80% dataset for training and 20% for testing. The next module is run LSVM algorithm. Using this module, we will input 80% dataset to LSVM algorithm to train a model, and this model will be applied on 20% test data to calculate prediction accuracy. The next module is run QSVM algorithm. Using this module, we will input 80% dataset to QSVM algorithm to train a model, and this model will be applied on 20% test data to calculate prediction accuracy. The next module is run existing naive-Bayes algorithm. Using this module, we will input 80% dataset to naive-Bayes algorithm to train a model, and this model will be applied on 20% test data to calculate prediction accuracy. The next module is comparison graph. Using this module, we will plot comparison graph between all algorithms. The last module is predict COVID-19 from test data. Using this module, we will upload test data, and then the best performing model will predict type of COVID-19 disease from test data. Execution of the project. To execute this project, first we have to open the code folder. This is the dataset folder in which I have the required dataset. This is the model folder. In this folder, I have the NumPy and Pickle files stored, which contains the algorithm information. These files can be loaded into the project code during runtime to utilize the trained models. These are the Python main code files. This is the text document which contains the dataset link to download the required dataset. This is the run.bat file. Instead of executing the project in command line interface, we have created the Windows batch file. Double click on run.bat file. This graphical user interface will be opened. With this, we are interacting with the program. Now click on Upload COVID-19 genes dataset. A dialog box will be opened. Select the dataset and click on Open. In this graph, on x-axis I have various diseases of COVID-19, and on y-axis I have the count. Close this graph, and in the text box we can see that the dataset is loaded, and these are the top 5 rows of the data. We can see there are non-numeric as well as numeric values in the data. So there is the requirement of pre-processing. Now click on pre-process dataset. So we can see all values are converted to numeric data here after pre-processing. Now click on Run ABE feature selection algorithm. We can see total features in dataset before applying ABE are 7, and after applying ABE, they've reduced to 5. And the total records found in dataset are 234, and this total dataset is split into train and test sets in the ratio of 80:20, and after splitting, train set includes 187 records and test set includes 47 records now. Now click on Run LSVM algorithm. This is the confusion matrix graph, and this is the ROC curve graph. In confusion matrix graph, x-axis represents predicted labels and y-axis represents true labels. And all different color boxes in diagonal boxes represent correct prediction count, and remaining blue boxes contains incorrect predictions, which are very few. And in ROC, x-axis represents false positive rate and y-axis represents true positive rates. Close this graph, and in the text area we can see the accuracy of LSVM algorithm and also the other metrics. And now click on Run QSVM algorithm. This is the confusion matrix graph and ROC curve graph of QSVM algorithm. Close this graph, and we can see the accuracy, precision, recall, F-score, sensitivity and specificity of QSVM algorithm here. Now click on Run existing naive algorithm. This is the confusion matrix graph, and this is the ROC curve graph. Close this graph, and we can see the performance metrics of this algorithm. Now click on Comparison Graph button. In this graph, on x-axis I have algorithm names, and on y-axis I have accuracy and other metrics. We can see out of the remaining models, QSVM is performing well in accuracy, F-score, precision and recall. Close this graph, and now click on Predict COVID-19 from test data. A dialog box opens. Select the test data and click on Open. So in the text box in square bracket, we can see test data values, and after the arrow, we can see predicted values as no virus, other virus, or SC2 virus. The conclusion here is Internet of Things devices are increasingly monitoring surroundings, including traffic cameras and patient vitals. The COVID-19 pandemic has promoted the use of Internet of Things sensors and machine learning algorithms to detect patients. An ABE feature selection algorithm is applied to overcome noise and irrelevant features, selecting high accuracy features. The San Francisco Internet of Things sensor genes dataset was used to predict COVID-19 disease. LSVM, QSVM and traditional live-based algorithms were trained with QSVM outperforming other models.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.